Well, welcome everyone to the technical webinar. What we're going to be talking about today is we're going to be talking about managing dependencies. I'm going to talk a little bit about independent versus dependent tests. And then I'm going to talk about managing dependencies. So this is where you have to have dependencies between tests. So when you do need dependencies, we're going to talk about managing them. I'll talk about all the different components of the solution that we've come up with, and then I'll do a live demonstration. And in case I forget to mention it later, if anyone is interested in the components of the solution that we've put together, you don't have to copy it off the slides. We're happy to send it to you. So if after the presentation you think this is something that you're interested in, just send support@xenix.com an email and we'll be happy to send you the project. So I'm going to start out by talking about independent tests. Now I'll make a case for independent tests because where possible, you really should strive to have all of your automated tests run independently. And there's some advantages to doing that. If you can do that, then it gives you the advantage of being able to run your tests in any order. And that might not sound like a lot, but let's just say, for example, that there's a few tests that you want to run because maybe there was a bug fix and you want to verify it. You don't want to run everything, you just want to run a few tests. Well, if all of your tests are sort of a chain and they need to be run one after the other, then that would mean that you'd have to run a whole lot of tests in order to get the result of whether or not the bug was fixed. Whereas if they can run in any order, meaning they're independent, then you could just pick out the tests you need and run them. The other issue sometimes with dependent tests is, let's just say that you do have a regression, a bug, in one component of the target application, but maybe not the part of the application that you're interested in on a given day. But if your tests are all dependent upon each other, then that issue or regression in one component of the target application could prevent you from testing other components that really have nothing to do with the fact that you have a bug somewhere else in your application. So it could limit, when you have dependent tests, it can limit what you're able to run because there could be problems in other aspects of your application. The other advantage, I think, of independent tests is that it could reduce the test cycles. And what I mean by that is that if you create your data states already in, say, the database of your target application, you've already got your customers' input into the application that you're going to use in your automated test. You already have, your inventory or whatever it is that your application does. Then your test can be based on, what I'll call a day zero database. It'll have everything you need to run your tests already in the database. Well, that could shorten your test cycles because that means that you're not having to run tests just to get data into the database so that then you can run the tests that are dependent upon those tests. So the fact that you create tests that are independent could shorten your test cycles. So these are the advantages that I see in, again, striving for tests that are independent. Now, sometimes we can't get around the fact that some tests need to be dependent upon others just because of the application itself. So we recognize that. And so sometimes you do need to build tests that are dependent upon other tests. One of the issues, of course, is that a subsequent test can't possibly succeed if an earlier test fails. And that's something that we have to recognize when we build dependencies into our tests. So what we want to do is that if we're in a situation where we know we have dependencies, we want to prevent those tests from running. So there's no point in running a test that can't possibly succeed because a previous test has failed. So the idea of managing dependencies is, let's signal or put a flag up when an earlier test fails so that a later test doesn't even try to run. Because I don't know if you've ever been in this situation, I certainly have, where you've got, thousands of tests that you're checking out when you're looking at the results of an automated test run. And when there are tests failing and it's not clear why they failed, well, then you have to, think back about, well, okay, this didn't pass because something happened earlier in the regression. I've seen some regressions that are built that way, and frankly, it can be a nightmare to try to figure out what went wrong when you're checking out the results. So it would be better not to even run tests that can't possibly succeed because an earlier test has failed. And that's really what I'm going to show you how to do in this presentation, because then you're going to be able to clearly distinguish between what really is a failure in the application and what is really just a failure because there was an earlier failure. Okay, you're interested in the earlier failure because that may be a real bug in the application, but you don't want to have to be cleaning up, the mess or figuring out what went wrong in the later tests. What this is really going to do is help you reduce the time that it's going to take to analyze the test results. Now, I've got a solution that we've created, and I'm going to go through all of the different components of that solution. I'm going to explain them all to you in slides, and then at the end, I'll actually run it, and we'll look at what the results look like. The first thing you'll notice is I'm going to be taking advantage of a feature in AscentialTest with test identifiers. So that's the first thing I'm going to talk about. I'm going to be talking about how I've modified, the onFinish of my app state. We'll take a look at the test case status.ini file that keeps track of whether or not a test has passed or failed. Then there's a couple of, there's a function and a step. There's a function called return PreRequisite TestStatus. This is going to return whether or not a prerequisite test passed or failed. And then there's a step that you actually put into your test that calls on that. It checks the prerequisite status. And then finally, another test or step, you can do it either way, that will remove the test status file in the beginning of a run so that you don't have old results. So we're going to look at each one of these components now. Now, this first feature that I'm showing you may be something that you're not familiar with, and it really doesn't have anything to do with our topic this morning. It's just that I'm using this, but you might be interested in it otherwise. In AscentialTest, there's something called a test identifier. And what this does is it provides a unique ID for every single test in your project, in your testing project. And to enable this feature, you go to your project settings and you find the test identifier tab, and then you click the enable checkbox. Now, once you do that, you also have the ability to format how you want that identifier to look. But the default one is your project ID, and I'm going to show you where you put all this in. Your project ID, your plan ID, and then the node ID is generated automatically. And this is a GUID that AscentialTest generates, and it's going to be unique for each test plan. And it's persistent, so it's not ordinal. So if you had tests, 10 tests in the test plan, and you delete the first one, it's not going to change the GUID for the other ones. They're going to keep the node ID that they always had. It's persistence. It's always going to be there. So you can rely on that. So again, looking back, you've got a project ID, a plan ID, and a node ID. So this is how you set the first two values. The project ID will automatically show up in your project data. So once you enable the feature here, you're going to see the project ID show up in your project data, and then you can give it whatever you want to call your project. I usually just name it for whatever my project is, but that's entirely up to you. So this project is called Dependent Test Example. Then in your plan, you put in a plan ID. I typically just make it the name of my plan, but it can be anything you want it to be. Now, like I said, that third part is automatically generated by AscentialTest, and it's a unique ID. I said a GUID, that was incorrect. It's just a unique ID. But again, it's not going to change. And here you can see the entire test ID. So if I click on this particular test, you see there's the project ID, Dependent Test Example. Here's the plan ID, and then here's that automatically generated ID. And again, if I delete, so this would be 1, this would be 2, this would be 3. But if I delete it, it's not going to change any other IDs in the plan. So that's your complete test identifier. Now the next component is what we've done to the onFinish function in your app state. Now, what I did was I created a different onFinish for my dependent tests versus my independent tests, but I actually made them the same. So the reason I did that was I was thinking, well, maybe I might want to change something else about the app state for the dependent versus the independent tests. So I separated them. You don't necessarily have to do that. I did it just for sort of future planning. But right now, by default, my onFinish for my dependent tests and my independent tests are the same. And so let's take a look at what we're doing in this onFinish. So the first thing we're doing is we're querying that test ID. So the data store query test ID and assigning it to this variable. Then we're creating a handle to the INI file, and we're opening up the INI file. And you might have noticed I had put the path for my test case status file in my data store. If you want to hard code it, that's okay too, but I did it via the data store. And then here's the name of my file, testcasestatus.ini, which we're going to have a look at together in a minute. And what happens is that when a test runs, we check to see what the error count is. If the error count is greater than 0, then we fail the test. Otherwise, the test passes. And you'll see what that looks like here. So this should be recognizable now, right? That's my test case ID, project, plan, unique identifier, and the status of pass. So it is this on start. Let's go back. I got to go up. There we go. It's the onFinish that's actually setting that value, that status value, to fail or pass in the test case status.ini file. So it's in the onFinish of every test case, whether it's a dependent test or an independent test. Because remember, a dependent test could actually be a prerequisite test for another test. So there's no guarantee that even a dependent test isn't again, a prerequisite test, because there could be a whole chain of tests. It's not just necessarily a one-to-one. It could be a whole chain of tests. So again, that's what it looks like. Every test has a status, whether it passed or failed. Now this function returns the status of the prerequisite test. So it's been written as a function. You can tell that because it's got a return. And so here we have a string test status, and we've got the INI file. Here we're opening up that INI file that we just looked at. Now the last time we were doing a set, this time we're getting the value. So we're getting the value based on that ID, a test ID that gets passed in. See, the path gets passed in. If it passes, then we return true. If it fails, we return false. So you can see there's no complexity here. These are really quite easy functions. So far what we've seen is we're writing to and reading from an INI file that's keeping track of whether or not a test passes or fails. So that was, again, remember, a function. Now I've written a step called CheckPreRequisite TestStatus. And so what this step does is it actually calls that function. So remember, that was called return prerequisite test status. It's right there, the one that we just looked at. So my step is calling that. And I want to explain how this works. So what comes in is the prior test. So the ID of the prior test. Whether or not this is a flag, it's an input parameter, whether to raise an error for a not run test. Because you have a choice here. You could either raise an error, which will up your error count, or instead, you can raise your warning instead. And the reason why I did that was because, remember, a test that is not run might not necessarily want to be counted as an error. And this gets into how you guys report your test statuses, your errors. So this solution has given you a choice of calling that an error. When you can't run a test, we're going to call that an error. Or you can call it a warning instead. So let's read through this, the actions here to make sure that that's clear. So we start out by setting this warning raised to false. And then there's a print statement that says this test has a dependency on, and then here's the prior test. If the prerequisite status, I'm calling that prerequisite status, is true, then the test will run. Otherwise, the test will not run. So if the prior test has failed, the test is not going to run. But here's where you get to make a choice. If raise an error for not run test is set to true, then we throw. And you probably know that if you throw, that's the end of the test. It's not going to go any further. So we're going to raise an exception, which is going to up the error count by 1. And the message is going to print out that says, this test cannot be run because the prerequisite test has failed. Now, if you don't want to raise an error, we'll go into the else, and instead, a warning is going to get logged. And it says this test cannot be run because the prerequisite test failed, but it'll be a warning. So it'll up the warning count, not the error count. But if we're going to do that, we're going to need a way to halt the test case without throwing. So we're going to pass back an out parameter is going to come out with this warning flag, and I'll show you how that's going to be interpreted in the actual test that calls the step. We'll look at that in a minute, but I want to finish the components here. The last component is called remove test status file. Now, I gave you two ways of doing that. This one happens to be a test, and you'll see this is the way I implemented it. I put this test as the first test of my test plan, and basically all it does is it just deletes the INI file so that we're starting fresh. Now, the downside of using it as a test, of course, is that it's going to up the number of tests. It's not really a real test. It's really just a utility that's going to delete it. So if you don't like the idea of adding a test to your metrics, I created a step version instead. And you can simply drag that step into, the first test of your regression, and then it won't increase the test count. So that's up to you. In my case, it didn't matter to me, but if it does matter, I created a step version just in case. Okay, so now that we know about all the components, I want to talk about how you implement those components into a full solution. So you'll see what I'm going to do is I'm going to add that step, check prerequisite status, to each one of the dependent tests. Whoops. Each one of the dependent tests in my regression. Okay, you don't need to put that in the independent tests, but you do need to put it in the dependent tests. And then you have to make a decision whether or not you want to parameterize it to the test plan or you want to bind it to a data table. You can do either. I'll show you that. I've decided to do it in the test plan because I felt like it was clearer. But again, you can do it in a data table if you prefer that way of doing it. And once you do that, then you're going to set the parameters for the dependent tests in either the test plan or the data table. So let me show you how that's done. It's actually quite easy to implement. So here's an example. So here is a dependent test. So this is, I just called it test with a dependency. And you can see that what comes in is the prior test and whether or not we want to raise an error. Whoops, I keep clicking and I don't mean to. And so I drag that step in, and so there's my prior test, and there's whether or not I want to raise the error. Remember, this is the step that we just looked at. So I drag that step into my test. Warning comes out. And if the check prerequisite status step warning is true, then we return. So that means that the test isn't going to run. Remember, if the test had halted inside of check prerequisite test, it would have halted. So we'd never even come back here. You'd never even come back to the test because the test would have halted right there. But if you opted to have it warn instead, then it does come back. But if it checks to see whether this is true, and if it is, it returns. So if it doesn't throw and it doesn't return because of the warning, then the rest of the test will run. And I just put a placeholder here that says the steps that make up the test will be placed here and they will run, because in this case, the prerequisite test has passed. We'll look at this live in a minute. So here's the plan that we're actually going to be looking at in a moment. And what I did was I put in the test that removes the status file. And then I have a test that passes. And my tests are just either printing something or raising an error, because I needed examples for you of a test, a prerequisite test that passes versus a prerequisite test that fails. So here, this test passes, and the dependent test will be able to run because the prerequisite passes. In this case, the test fails, so the dependent test does not run, and in this case, you'll see it raises an error. In this case, the prerequisite test fails, but the dependent test raises a warning. And we'll have a look at both of them in the test plan. But here you can see I've got a dependent test. And remember, I said I parameterized it to the plan, which means that instead of having a data table where I'm going to set my parameters, remember there's the two parameters, the prior test, so that's the ID of the prior test, and whether or not you want to raise an error for a not run. So I parameterized it right in my plan. If your preference is for binding to a data table, you could do that as well. Okay, so let's take a look at it live now. So here's my my plan. And remember, if you want to look at what a test does, you just double click on the T. So again, you can see my tests are very simple. My example test, it just says this test passes because that's all it does. Whereas if we look at the one that fails, you'll see I'm throwing an error because I just want to create an error. That's the whole idea here. And if we look at a dependent test, you can see here's the step. I'm passing it the prior and whether or not it raises. And if I double click on the blue keyword step, I can go right into the step that I showed you in the slide. Let's go ahead and run this. So I'm just going to run the whole thing. It doesn't take very long. Okay, now we have a result. And let's take a look at what we got back. So again, this is where I was talking about, if we look at our summary, we see that we had 4 tests that have passed and 3 that have failed. And this is where I was saying, remove test status file. That actually gets counted as a test, even though it's not really a test. So if that bothers you, that we're counting that as a test, then instead of using the test, you can use the step version and put it into the first test. That's what I was really talking about there. Now, of course, this test passes, and it just says this test passes. And the dependent test is going to work because this test is dependent upon this guy right here. Oh, and if you want to see the test status, let's see, we can go, where do we see that? If we go here, and here's that test ID right here. So if you're wondering, well, where do you get the test ID for your dependent test? Here's the test ID. You can copy that right into here. So there's where you put the prior test. So this test is dependent upon this test. So you want to put the ID of the test that you're dependent upon right here, and whether or not you want an error to be raised. And so because the prerequisite test has passed, the dependent test will run. And again, I just have a placeholder there. Whereas here, my test failed. Now this is an independent test. It failed. And the dependent test doesn't ever run. So you can see that, I've got that print statement that says this test is dependent upon number 3. The test will not run, and it raises an exception because the prerequisite test has failed. Which, if you look back at the summary, that upped the error count. So you might think, well, if you don't want that to up the error count, because this is a real failure. This isn't really a failure. It's just that it couldn't run. So if you don't want that to happen, then you're going to implement this solution instead. This test really did fail. But then this test, it gets a warning instead. Now, currently, AscentialTest doesn't have a symbol for when a test is not run. Now, you do have that if you were running from, a test set where the test was actually not run. But we don't have a symbol here in the plan. And even if I was to run this from a test set, this still would come out with a green check mark. So in the future, we'll make some changes to AscentialTest, to handle this idea of dependent tests. Right now, we've written our own components, but we could build them in and give a new symbol so that you could see whether or not, this was just a not run. This should really come out as, a different symbol. It shouldn't really be a green check mark because it suggests that the test passed, and it didn't. It really just wasn't run. But it does prevent you from having to spend time trying to figure out whether or not there's a real failure here or not. In fact, that's even true here. So imagine yourself checking out a regression of hundreds or thousands of cases. And the typical procedure is you start at the top and you look through all of your failures. Well, this test failed and you see why. But then when you came to this one, it would be really clear right from the beginning that this test cannot be run because of prerequisite test failed. So you're not going to spend any time with it. That's what's really important. That's true of, this one you wouldn't even know. So there's some advantages and disadvantages of either. This looks just like it passed, although you do get a warning. Okay. Whereas this one ups your count, but it's clear from the error that it didn't run. So again, we'll look at this one here. This one failed, but because this test, if we look back at it, this test put in the prior test, but it did not send a true for raise error. So this was set to false, and that's why this one didn't fail. Instead, you get the fact that it didn't run, but you get a warning message instead of an error message. So you can see this solution is not difficult to implement. There's really only a couple of components that we've created, and of course, since it's a utility, it shows up right here in my Actions Explorer. And so if I double click on it, here's that return prerequisite test status. It's written as a function. And then the steps, so that's where that is stored. And then the steps would be right here. So here's my check prerequisite test status and my remove. So I have a separate group. You might have noticed that I have a group called test dependency, just so I can find them very easily. I use my description and I use my group so that it's very easy to locate those test dependency steps. Remember, I showed you that I had created a test to remove the test status, but if you didn't like that, then you could just drag the step into your first test. And again, if you want to look at my onFinish, you see there's my onFinish. And if we look at the one for the independent test, they're identical right now.